Hello everyone. In this video, I will show how to create an individual head model for source analysis in Curry 9. This head model can be used for epilepsy data as well as for event-related potentials data stemming from EEG and or MEG. Let's switch to Curry and look at the data we will use for this example. On the left side in the user interface, look at the database, expand it, we can see that we have one subject, and this subject contains a study, which itself contains an averaged file of an epileptic spike. If we open this file, we can see the traces of this average, and we can take a look at the data by choosing the Alt tab. We can see the topographical maps, also the 3D view scenario, and now the inbuilt image data. We can change the view of the functional data to a butterfly plot, which plots all channel traces superimposed. And we can also change the cursor to look at the topographical maps. I will place it at the peak of the spike. And what we can now do is to perform source reconstruction. We can go to the source reconstruction tab in the parameter pane and choose a head model. So we have several choices. We can choose one of the spherical models. There's the infinite homogeneous, or we can also choose the BEM precomputed, which is a realistic head model. And while it is better than the spherical models, it will not exactly match the geometry of the head of our subject. But I will use it for now and then compute a dipole fit, moving dipole fit, and we can see that we already have a dipole here, and I will also run an S-Loretta current density reconstruction, but I will choose to run this on the standard cortex. And if I go to the 3D view scenario, I can see that we have a result. However, let's now use an individual head model. For doing this, we need the MRI of the subject. And let's import that data to our database. So let's right click in the subject and choose to insert an image data folder. I will navigate to where I have the MRI data for this subject, add it to the subject, and now the image data parameter window will come, and Curry will automatically detect the parameters of this DICOM dataset. We can review this, and we can optionally adjust this, but Curry normally does a good job detecting the right parameters. In this case, we could apply a bias field correction, which will mitigate the bias field artifact commonly present in images from high Tesla scanners, and in turn improve the segmentation algorithms in Curry. We can review the thresholds that are used for the internal segmentation and just import the dataset. Here we can define the landmarks. I will just leave them as they are. And now we have imported the dataset. I will open the BEM-FEM geometry panel in the image data tab and just press start. Notice that for EEG, we recommend to use the BEM head model because it offers the best compromise of accuracy and computation time. However, there are other available models. If we take a quick look in the create list. So there is this BEM, MEG, ECOG, a special model for MEG, and also electrocorticography. And there are also the FEM models, the FEM head model. This would be for EEG. Then there's the intracranial for depth electrodes, as well as cortical grids and strips. And there is also the mixed FEM, which can handle both scalp electrodes and intracranial. And then we can also create some other segmentation results. But now we see that Curry has finished the segmentation. This segmentation created 3 compartments, which are the inner skull, the outer skull, and the scalp. And it also created a segmentation of the cortex, which can be used for visualization and also for the computation of cortically constrained current density reconstructions, for example. So let's go back to the Alt tab and use the individual realistic head model we just created. We can do this by changing the selection in the head model list, and we can choose the BEM 6, 8, and 9 millimeter. These are the resolutions of the triangle meshes for each compartment, and this number is the number of nodes in the mesh. So I will now select this model, and I also need to change the source location. We can select the cortex that was obtained from the MRI of our subject, and let's select that. And now let's take a look at the result in the 3D view. We can double click in the cortex object and look at its properties in the 3D view objects list. So this is the object, the CDR S Loretta, and we could show the pile surface, which is a more realistic representation of the cortical surface. So we can inspect and see that the S Loretta points to an activation at the tip of the left temporal lobe. To summarize this video, we have shown how to use the BEM pre-computed head model when we do not have MRI data from our subject. And this is a good option because it is a realistically shaped geometry. However, if we do have the MRI of our subject, we can create an individual realistic head model and use this for source reconstruction. Thank you for your attention.